Thank you for joining us today. Welcome to our Bricks Smart Sewer webinar. Did you know the EPA estimated that it would cost $630 billion to overhaul the wastewater industry? That's one reason we're here today. Hi, I'm Katie Strauch, Marketing Coordinator at KCI Technologies, and I will be the moderator for today's webinar. I'm joined by my colleagues, Catherine Brill, Senior Products Manager, Jay Kwan, Sales Engineer, and Carl Keller, Senior Systems Engineer and leader of our Machine Learning Operations team. It is our pleasure to talk to you today about the evolving role of artificial intelligence in the wastewater industry. Let's get started. For those of you who do not already know, KCI is a leading civil engineering firm with a focus on technology and innovation. Today, we will discuss the industry standards for sewer pipeline assessment, how AI can transform sewer pipeline assessment processes, and our bricks models that optimize workflows for wastewater engineers. At the end of this webinar, we will have a brief Q&A. Please feel free to drop your questions in the chat, and we will address them during this time. I will now turn it over to Catherine, who will briefly discuss the current challenges in the wastewater industry.
Thanks, Katie, so much, and welcome everybody. Thank you so much for joining. We are very excited to have this webinar and talk to you about AI in the wastewater industry. Our products team at KCI is committed to developing and bringing to market emerging technology to users within the architecture, engineering, and construction industry, and that includes water and wastewater. So we worked very closely with our engineering staff within the larger KCI organization, taking advantage of their many, many years of experience, expertise, and success to learn more about and really understand the challenges and pain points in the wastewater industry. Now, I have put together some statistics. They're on this slide, and they're pretty alarming on the state of the wastewater infrastructure in our country. So we've got 2.2 million miles of sewer pipes in the United States. Unfortunately, in the most recent ASCE 2025 infrastructure report card, the wastewater industry received a grade of D+. And it was estimated in that report that there's a $99 billion annual investment gap for the water infrastructure as a whole. So poorly maintained sewer pipes definitely have a direct and immediate impact on so many aspects of our daily lives. When a sewer pipe fails, there can be traffic delays, property damage, loss of service, major financial burdens, including having to hire emergency personnel and having to pay EPA fines. But I also want to stress the significant environmental hazards that come from SSOs and leaks. They leave a tremendous impact on our entire ecosystem, impacting our own health, destroying our natural ecosystem, adding bacteria to our bodies of water, killing off aquatic life, and also spreading disease. So, sewer pipeline assessments are critical to maintaining our underground infrastructure. We put together a small animation of what is a common approach to conducting pipeline assessments. So typically, a utility or a municipality will hire an inspector to use a special camera system, a robotic crawler, to go down through the pipe and capture data. A skilled operator on a truck is guiding that camera system through the sewer pipes and then labeling defects found in real time using industry standards that have been established by NASCO. I'm sure everyone knows what NASCO is abbreviated for, but it is National Association of Sewer Service Companies. Then, After all of that data has been captured, we get to the next stage. And that is that CCTV video of the sewer pipeline must be reviewed to check for the quality of the labels. Were any defects missed? Were any misclassified? This involves an engineer or a project manager or a technician to review hours and hours of CCTV video, which, as you can imagine, is a very time-consuming and tedious task. In the next step, the Standard Exchange PACP database, and that's part of the inspection data that is delivered to the utility or the municipality, it needs to be reviewed. This file includes coded classifications, ratings, grades, and metrics for the inspection. From all of this data, a list of recommendations for remediation and repair is created, along with cost estimates. And that is then delivered to the utility or the municipality, and they use those ranked recommendations to help them with maintenance planning and scheduling, as well as budget planning. As you can imagine, there are many challenges to the analysis component of that overall sewer pipeline assessment workflow. It's time consuming. The watching of the sewer pipeline video takes a long time, very labor intensive, introduces a lot of potential for human error. And this is important that, we can't afford to have human error when we're trying to fix our infrastructure. And also in general, there's just a very large volume of data that needs to be processed. So that's a brief background on the sewer pipeline assessment workflow. And now I'm going to hand it over to Carl, who's going to talk about how AI can help optimize that.
Okay, well, thank you, Catherine. It was a great intro. As everybody probably here realizes, that the engineering workflow that we understand is really what's driven our technological approach. So we purposely did not take a one-size-fits-all kind of approach to this problem, because there are very different functionalities involved at each step in the process. So I'll just kind of go through the approach that we took for each of the three areas that are highlighted there in our workflow. In terms of a quality control review, we chose neural network technology, which has been advancing fairly steadily for the better part of a decade now in computer vision. And so these computer vision systems are getting mature enough. They have significant capabilities in terms of their MLOps support and pipeline, for life cycle development of these systems, so that they seem like a reasonable approach and not a risky approach to supporting the QC process, which is inherently a visual process. And so we began the process of building our own neural network vision systems based on data that we had, and began building that out according to the NASCO defect standard for PAC-P. For the computational element, that center piece, once the defects have been approved and we know really what the deficiencies are in the pipeline, it's time to compute the grades and metrics. And we chose to implement that as Python code. So those grades and metrics and the code that computes them are actually part of our DevOps practice, and separated out as a distinct code base. And I'll get into a little bit of why we're sort of taking this modular approach to this in a second. But that actually worked very well for us. We felt it bridged a gap that we saw in the Exchange database that exists, that I'm sure everyone's familiar with. And we saw some limitations there just in terms of the fidelity of the data and results, and felt that it was a good thing to be pulling those out. So we did re-implement grades and metrics calculations according to the NASCO standard. And then finally, for the policy component that's driving the recommendations and remediation plan for the pipeline, we chose more tried and true AI technology for that, called knowledge-based systems or rule-based systems. These are inference engines that do pattern matching against data. So we wrote rules to implement our policy and automate it that way. So that policy reflects really our engineers' understanding of how you'd actually make decisions about what to recommend after you have all of the data prepared for you. Now, in terms of our general advantages in taking this approach, number one, it's a modular approach. Like I said earlier, not a one-size-fits-all. We could have, of course, jumped on the AI/ML bandwagon. I've been in that since 1985, so I've seen a lot of ups and downs in AI technology. And as we analyzed these different areas, it just didn't seem appropriate. And generally, the industry, I don't think, is quite ready, for a fully ML style of approach. And frankly, we didn't have the data to support that for particularly the last step, the policy automation step. And it also kind of flew in the face of what people are actually doing today, which is valuable. They're doing quality control, they're storing data in databases. So we moved in line with that to try to be enhancing the process rather than disrupting what was going on. In terms of some of the needs that drives for us, well, we certainly have to have high quality imagery for the CCTV inspection processing that we do, and to be able to build quality models. We also have to have enough training data in the form of class annotations. And for that, we invented our own ML ops pipeline and have implemented that and staffed that. So we have models today that are supported by a team of ML ops engineers capable of doing correct annotations and correct model building. And they're familiar with multiple types of models as well. And then we also have hooked in active learning to that process. So as our clients begin using this system, we're able to encourage them to allow us to make the system better by using the data that they bring in. And our active learning component actually gives us a leg up on continuous improvement in the vision technology, which is where the learning is occurring. Finally, there's an ongoing and active QC and QA process internally in our team, where other parts of the team are engaged in measuring the performance of these systems. So it's been a good process of developing the infrastructure required to support such a large and important effort like this. And so we're tooled up to be able to do that. Overall, I'd say that in kind of summary, I would say we took a very systematic approach to building the system. It wasn't piecemeal, and we were leveraging to the fullest extent possible all the work done, of course, in the NASCO standards and how they're not only implemented but described in the industry. So we were in line with that. We also committed to a full life cycle development activity. So we have both MLOps and DevOps involved in maintaining the code base. And we're growing our knowledge of policy right now and looking for future ML support as we begin to grow that even larger. So that's it in a nutshell. I'll pass it back to Catherine at this point.
Thanks, Carl. Thanks for explaining that. So all of that AI and machine learning technology that Carl was just describing, we brought it to market along with developing the infrastructure to run all those models on. And we launched Bricks. It is a cloud-based, secure models of service platform that offers a variety of AI models for different markets, including water and wastewater. Bricks provides a way for engineers, project managers, staff members of local or state government agencies, other consultants to reduce the risk that's involved with adopting emerging technology. The way that we're doing that is we are delivering pre-trained machine learning models that are ready to run, along with the infrastructure to run those models on. As we had talked about for the wastewater industry, Carl's already gone through what we've developed. I wanted to show you briefly what it looks like in bricks. We have two models. Sewer pipeline defect detection uses computer vision to detect sewer pipeline defects within CCTV video. With this model, the QC process is optimized as hours and hours of manual review work can be eliminated. Smart Sewer Repair is another model that optimizes the analysis step of that overall pipeline assessment workflow. With this model, the grades and metrics in the PACP database file is analyzed automatically, and recommendations for sewer repair are generated and to accelerate budget and maintenance planning. I think at this point, I want to show you briefly how accessible and easy to use those models are on bricks, as well as the output. So I'm going to go to, you should see, please let me know if you don't, but you should see my bricks browser. And here is bricks, gobricks.com is the URL. I highly encourage, maybe someone can put that in the chat, Katie. I would highly encourage that you go and check out all of these different machine learning models, all different markets within the larger AEC industry. For the purposes of this demo, I've already logged in, and you'll see I'm logged into our test environment, and you'll see I've got my catalog, but now on the left-hand side of my bricks portal, I have more functionality. This is where you can upload your data. Once you're logged in, you upload the data that you want to run through your models. And also by clicking on the results option on the left-hand side, this is where, once your model is done running, you can access your model results. You can view them, you can download the files and manage your output. So I'm going to go back. We have a personalized dashboard as well if you want to have some analytics on usage, but I'm going to go back and start showing you our models. This for wastewater. Sewer pipeline defect detection. Before I start running the model by clicking on Run Model, I'm going to show you some details. These are all the different defects, structural and operational and construction defects that our model currently detects. You see here the required inputs. We accept still imagery as well as CCTV video. And then the output, once you run your video through this model, you'll get an annotated video as well as a summary report. So I want to show you what that looks like. Going back to my catalog to run my model, I start the model run by clicking Run Model. I can select my video, select Next, give my model run a friendly name so that I'll remember it, set some precision recall parameters if I like, review what I have set, and then start my model run. Once it's done, you're going to see it in my results page, but I've already run it for you, and I want to show you our video output. So here's a great example of an output of our sewer defect detection model. It is detecting all the defects. I'm pausing now. It's detecting all the defects that's found. As a user, this is very handy. I can speed up my video if I want to really help optimize that QC process. Now here, I'm going to pause for a second. Here you can see that the model, our BRICS model, is picking up two types of fractures, FM and FL, which is excellent. But if you notice, and I'm going to keep on going a little bit and then pause it again, our model actually detected more than what the original human operator detected when they were running their camera through the sewer pipe. And in fact, you see here, the defect that we ended up detecting was actually even more serious than the FL that the operator detected. So that's a really good example of how our model can be used to help optimize the QC process. Now, an annotated video is not the only output that model deals with. We also output a spreadsheet. So in this spreadsheet, you'll see total counts of all defects found, as well as, lost my go back to our catalog to show you the smart sewer repair model. In this model, it is, as I had mentioned, analyzing the PACP database file, where all the grades and metrics are, and it's pulling together and generating the following common recommendations: manhole to manhole steam cured, manhole to manhole UV cured, pipe replacement, root treatment, light cleaning, sectional lining, and test and seal grouting. And so I wanted to show you something really important with this model. Once you get your database and start configuring your model, you'll see here that I can actually edit my pricing. So we've set this up with some standard default pricing for these repairs, but depending on your region, you might need to adjust those. And so we give you that capability here. So you can adjust your pricing before you start your model run. And once the model is done running, here is a good example of what your output file will look like. All information about the inspection is laid out. A lot of this information has already been entered by the inspector on the truck or the field technician who's reviewing the inspection data. But then you'll see there's grades by code listed for each pipe segment, as well as the likelihood of failure rating, the recommended repair based on our analysis. All this is automatically generated, the priority of that repair, and how much the total price will be. So we have used this internally, and an engineer who was working on a medium-sized project for their client found that this smart sewer repair tool saved them a considerable amount of time. 40 hours was estimated as a time saving, which really is huge. So I'm going to go back to the slides. And I think this is the last slide I have before I hand it over to Jay. But as you can imagine, our wastewater models are delivering value by providing optimized efficiency, cutting the QC hours, cutting expenses, saving time, freeing up resources. If you're a consultant, you don't have to spend hours and hours and hours reviewing CCTV video or pulling together recommendations and looking for costs. Instead, you can focus on other tasks. You can also extend your capacity to take on more projects. And basically, what I want to stress here is that our models are reducing overall costs with very, very minimal investment required. So now I think I will hand it over to Jay to talk about more cost savings.
All right. Thank you, Kathleen. So my slides is something that Kathleen already mentioned a few times, kind of going over one more time. So as you can see here, if you are following with the NASCO CCTV review, which is one-time review it will cost about 25 to 50K on it, where we could avoid the roughly 5 different issues, which is such as the avoid the emergency repair, extend the sewer pipeline lifespan, improve the rehab decisions, reduce survivability costs, and optimizing cleaning schedule. However, if you are just stick with it, you wait for the last minute, and the inspection costs will be continually keep going in. So if your initially spend about 25 to 50K, where you could save tons of the 100 to 500 $1,000 for each project or each cities on it too. And then can you please move on to the next slide, Kathleen? And the next slide is about, okay, so how can I do it? Now you can actually use the bricks. Then what are the little bit of the investment that I'll need it, and what are the return that I'll receive, right? So we also showing you in two ways in this graph. The first graph is about user bricks and window mode model, window mode projects on it. So one run or one project of the inspection will cost about 200 to 400, where it's gonna save your time. So therefore you'll be opportunity to window more projects. So that way, as time goes on, you will run many more projects on it too. And another benefit about using bricks is there's a no data size limited on it. So you can throw tons of the data into it, and within the one run, you'll be able to see all the detection and all the result coming out to you. And secondly is, I think this is one of our biggest selling point which is a time saving. Each project, it would take about 40 hours, but however, you can get it done with the bricks within the 20 hours. So therefore, you have an opportunity to handle 2 projects instead of one project within the 40 hours. So overall, this is the what benefit that we as a KCI using the bricks will be benefit to the wastewater engineers.
That brings us to the end of today's webinar on AI in the wastewater industry. We hope you found it valuable and insightful. A huge thank you to our speakers for sharing their expertise and all of you for joining us. We would greatly appreciate if you could complete the survey. I just have attached it to the chat here. We encourage you to visit gobricks.com, view our product catalog, view our blog at blog.gobricks.com, and follow Bricks on LinkedIn. For any additional questions, please reach out to Jaquan. Thank you again for your time and participation. We look forward to seeing you at our next webinar. Have a great day.